Hello, and welcome to the talk on building trusted software supply chains, the DevSecOps journey. My name is Henri. I'm with VMware in the Modern Application Business Unit. I've got a background in real-time power grid operations and financial services institutions. In both cases, I've seen a lot of supply chains and how to apply security and compliance practices. So today we're going to talk about how to accomplish these and how to apply DevSecOps practices. What's interesting in the physical supply chain business, we actually are able to achieve a level of trust, and we're able to inspect what is going on in the supply chain. I think, for example, how your medication gets to the pharmacist, or how the products go into the grocery store. You're able to see what's happening. So why is it that we're not able to address these challenges in the software business? So today we're going to dive a little bit deeper on how to apply these and how to leverage DevSecOps practices. According to the 2020 State of Software Supply Chains, we're seeing an incredible increase in the use of open source software. And let me pick a couple of observations from this great report. Number one, the universal desire for faster innovation demands effective use of reuse of code, which in turn leads to a growing demand and a set of dependencies on those open source and third-party libraries. Now, developers have this fast pursuit of faster innovation, are using public repositories in most cases, and as such are creating the modern software supply chain. Now, on the flip side, 21% of enterprises experience open source breaches, and that's a 430% year-over-year growth in cyber attacks in open source software. Now, we don't want to scare you with these things, but it's just an eyes wide open of what's going on in the industry. On the flip side, where we see some positive signals is that new standards are being created and providing guidance, such as NIST providing guidance on open source software security, but also recommendations on using bill of materials. But let's unpack this a little bit more as far as what's the real impact of these breaches. The energy industry, and specific the highly regulated industry, have seen a higher cost of data breaches according to the IBM cost of data breaches. For example, you can look here, the energy business has about 5.6 million versus an average of 3.8 million data breach impact. Now, the cost was higher due to relatively impact, for example, being in critical infrastructure. But the main driver has been the slow time to remediate those issues. Part of that is due to regulation, but there's some other causes to this as well that we dive in deeper. Now, what's interesting, if you overlay this data with the Verizon 2020 data breach investigation report, includes a 43% of data breaches could actually be traced back to compromises in applications. But let's now understand a little bit more what's impacting things positively and negatively in these data breaches. And if you look at the details, what's interesting is there's a couple of things that amplify these cost numbers. For example, in this case, compliance failures, which is very interesting because that implies that we have maybe some of the policies and the compliances are in place, but they're not getting the benefits that we really want. Or in my view, it's actually that we have compliance in the right places. It's just that they're not industrialized in a way that we need to. Now, on the other hand, we see that DevSecOps practices actually have a very positive impact on the cost, meaning that those practices are actually helping. So it's actually my hypothesis that we're able to by implementing effective DevSecOps practices, we can also ensure that the compliances get in place as well. And this, I think, is the key motion with DevSecOps as well. But first, let's take a look at how we can actually measure some of these things and the effectiveness of these. So typical risk-averse or highly regulated industry focus on stability, given their operational nature or critical infrastructure. However, this tends to slow down the throughput in those organizations. And as the previous report said, you kind of have to have throughput to be able to reduce the cost of these things. Now, according to the Software Supply Chain report, companies that have a lower mean time to remediate or update have a lower risk profile. According to the DevOps research, the DORA report, which published a yearly report called The State of DevOps, companies can achieve throughput and stability at the same time. So this sounds counterintuitive, but you're still able to do this. Now, given that in a world of 90% of our software is built on existing parts, it creates additional complexity, and we need to look at this from an overall supply chain perspective. As we think through the supply chain, research indicates that these key metrics for the supply chain are metrics we need to make sure we measure. Just like the DORA report measures just the DevOps side of the house, from a supply chain perspective, I think these are key metrics of mean time to remediate and mean time to update. And this really captures on how fast you're able to address a vulnerability, but also how fast you're able to update this. This really talks more to velocity side of the house. Now again, the other thing that the report indicated is that there's a set of other dimensions you can look at for the different open source projects. And here's a couple of them indicated. But a couple of key things are, again, highlighted as key. Mean time to patch, design for containers in your infrastructure. And what's interesting, some of the open source projects that are able to do this faster have roughly about 530 times faster mean time to update their dependencies and 2.8% more commits for exemplary projects. And also have 26% faster detection and remediation of those vulnerabilities as well. So to sum that up, is projects which update their dependencies more frequently are more secure and more reliable. Again, a key indicator of what you want in your supply chain. To highlight this faster as well, on the enterprise side of the house, it's interesting that only 40% of companies deploy software more frequently than monthly. So, like what I said, in the regulated industry, you actually want to get to a point that you release faster in your organization as well. And this is where some of the practices come into play. Now, to illustrate this more, the report kind of highlights two dimensions as well. One, if you want to create more risk mitigation strategies, right, on your security side, that's kind of what you see on the left side. And on the x-axis, you actually notice as well the performance side of the house. And the higher you go up in this particular graph, you see you get more secure. But it also highlights that you can be secure and going fast at the same time. That's actually the top right quadrant, where you see a great impact of high-performing organizations. You're able to get security and velocity at the same time. But we've talked a little bit about supply chain. So let's kind of dive into a little bit details what we mean by the supply chain. At the end of the day, supply chain is the flow of goods or products and components in the open source business that then transformed into an actual new product. But what's important is that the supply chain really highlights a set of trust capabilities or a network of trust between all the participants. Now, to build this trust, you need to be able to verify things. You need to be able to attest things. There's mechanisms that you need to have to establish this supply chain. And we'll dive into that a little bit more. But the other key point we need to highlight is the fact that the management of the supply chain is going to become more and more critical, like what I already indicated with some key metrics. So let's look at the phases. If you break down the supply chain, obviously you have the first part is the supply side of the house itself. In the supply itself, you deal with the suppliers that have to be reliable. Again, reliability also creates this trust capability, but you need to also be able to verify this as well. Next, you want to take your supply into inventory. So inventory allows you to control the supply chain, but also allows you to verify and create reliability for your organization itself. For example, you take the software internally in your organization. Also, next thing, if you're doing first-party development, you need to be able to assemble the components together. But also within your organization, create attestations and authenticity of the people that work on those elements. Next, you want to be able to distribute that in your organization in a way that you can look at the packages that are going into production and have a level of guarantee what you're moving into production. Finally, you also want to be able to deliver or bring it to your consumers. Now, this might not be the case in most energy systems. However, unless you're an energy company that creates software, you also need to be able to deliver this. And again, your customers then need to be able to verify authenticity and integrity of what's being delivered. But ultimately, we're in the business of creating flow in the organization so that we can look at compliance as well. Now, I always get this question, so where do the practices actually play? Well, I think actually the practices of DevSecOps really play in this middle middle ground. From the moment you take inventory all the way to you distributing and having a path to production, that's where your practices play. And we'll dive a little bit more into what the practices are. As you guys can tell from this image, supply chains can also be disrupted. And again, that's why I wanted to highlight the fact of that you need to have inventory, and managing the supply chain are critical to your business. But we need a little bit of a paradigm change. So part of the paradigm is also thinking through like what are the roles that are being played in what's the primary concerns that need to be addressed. So let's take a look at how we do that. But first, let's define DevSecOps again. So in the point of, from what Wikipedia, if you kind of read this, is you see that DevSecOps is really the next level of DevOps, but now you're applying security practices and integrating that into your overall model. At the end of the day, you're really addressing security concerns up front in the development lifecycle. And this is the whole mechanism that we've been kind of talking about, is the shifting left of those concerns. And again, applying those practices as well. But in the end, the ultimate goal is always to establish flow into the development process, right? Because we want faster velocity. However, there's a large usability pain as well for the developers. If you look on the left, the NPM packages, on how many dependencies there are, there's a lot of things that developers have to be concerned with. And usability pain really talks about this notion of if it's really hard for using the different pieces, the APIs, the upgrades, developers tend to reduce the time that they actually spend on actually updating the dependencies. So it's more things that are added onto the developer's plate in the long run as well. And what we're trying to do is actually simplify things as part of the process. So we'll address those concerns as well in the DevSecOps practices. Again, we're not trying to add more things onto the developer's plate. We're trying to streamline what the developers need to be doing. So let's take a look at it in the context of the different phases. Like, what are the things that we need to do in the supply chain? So first off, we want to start with having a set of validated upstream suppliers. We know that there's suppliers out there. We need to make sure we validate them. So by doing that is we bring this in-house and have the validated catalog of software components. We don't want developers and anybody in the organization to go directly out to the internet and download components. We want to have a control point where we can verify the suppliers and what they're supplying as well. So key things we're looking at is curated. Have we tested things? Does it have a bill of material that I can inspecting? And here's where you apply some supply chain management capabilities. Next, when we actually do the development side of the house, developers have a set of tools that they use. We want to make sure that we can verify those tool chains exist as well. Then when the developers build, we want to create a consistent build packaging mechanism that allows you to automate these capabilities. This is typically where you see like the CI tools come in, but this is more than just the CI tools. We also want to make sure there's key validations that occur in this particular space as well. Next, we also want to make sure we put these artifacts into a registry. In the case of containerization, a container registry, but there's more than artifacts that you want to put into a registry. But the key part is the registry is a secure piece where whatever you're putting in there is actually signed as well, right? And those images and artifacts actually get scanned as well for security vulnerabilities. And then next, we also want to have the validated sources go directly into the registry as well. This is in the case of third-party software, that you're using OSS packages that, for example, MySQL, actually move into the registry as well. Next, you also want to test and verify the components. Are they working? Are you validating that automated capabilities are in place? Can you do this in a secure environment as well? But then also, before you actually move into a production environment, you want to have some admission to, it's kind of like an admission to the production environment where you look at the set of controls as well before you move into it. And these controls are not verified in a manual way. It's all done done in an automated way as well. You can apply a set of policies before you actually move into the production environment. Next, as you distribute, you also want to place it into a marketplace type of construct or a repository where your customers can actually look at things like their entitlement, but also a bill of materials to look through. But let's now dive a little bit deeper into the different concerns that the different areas might have. First, let's take a look at the inventory or the supply chain management side of the house. Again, like what I mentioned is you start off with the upstream suppliers, but there's a couple of key inputs that you always look for. Things like bill of materials. Are there attestations? So are the suppliers attesting to what they have provided to and they did it in a secure manner? And also you want to look at vulnerability intelligence as well. Next, you put it in a validated catalog of runtime images and in the registry as well. So it's always available in a registry internally. This is where people should really be pulling their artifacts from. But next, all that information, ideally in the software bill of material, get extracted from the registry and the validated curated source and put into a way of performing risk analysis. And risk analysis really has to understand what the components are of the software, and this is where the bill of material really helps. You want to be able to look at the vulnerabilities, look at the licenses, because licenses might change and might not be conducive for you to actually consume anymore, and then identify a risk score. And we'll get to that. So risk is really a way of looking at the software from what's the likelihood that this might be an impact on me, and what is the impact on the organizations. Because sometimes it might actually be a very low impact if the environment cannot communicate to anything else. You want to make sure that when you do your risk analysis, you actually look at it at a quantifiable way. And this is important because it allows you to then rationalize of what you do with the software versus just looking at the number of vulnerabilities or the impact, or sorry, the way of thinking about the vulnerability. But also you want to bring in a lot of the external vulnerability intel, so you can have a lot of scoring based on what the vulnerabilities are. And next, you want to store this all in a metadata store, because as we go along, a metadata store really provides you a way of looking at attestations, vulnerabilities that happen, but also the risk scores themselves. So it kind of looks at the supply and inventory concerns that you want to address. Again, you want to create that trusted, validated catalog of data, but at the same time perform risk analysis on the data as well. Next, developers, it's all about productivity in the end. So they want to continuously build. They don't want to have to deal with figuring out what are all the vulnerabilities, when do I patch things, when do I bring in new versions. You really want to create a system that allows you to continuously build these things. But also what's important is that they attest to the things that the developers do as well. Like for example, if they do a check-in, they perform a unit test, it's attested to that they actually have happened. Again, simplifying your compliance and risk departments. Again, you take the catalog as well, but you have a build system that monitors those upstream sources. So for example, your source code, obviously, but also the third party, and then continuously build your artifacts. And this is where you can leverage systems like, for example, KPAC as an example, that continuously monitors these things and builds the system accordingly. And next, you also want to store those attestations, again, back in the metadata store so you can rationalize those. But from a build, you then push those into a registry as well. And the registry, again, continuously looks and scans the images for other vulnerabilities as well. So essentially, you create a system that continuously is up to date, but also has the latest information of vulnerabilities. Again, this information then feeds back into the metadata store as well. Again, during the development process, you can then continuously apply risk analysis as well, and give this as a feedback loop back to the developers as well, so that they have insights as to what the risk is. But this is where you coordinate also with your security department as well, that they look at the vulnerabilities, they do the risk scoring as well. So next, let's take a look at the operator concerns. So the operator concerns is about stability. But one of the key focus that I want to highlight is that instead of always trying to patch your infrastructure, you really want to start thinking about repaving your infrastructure continuously and kind of treating your infrastructure as ephemeral. And that way you never have to really patch pieces. You really put on new versions of your infrastructure. And the second thing is that you want to have a declarative state versus the imperative state. Declarative would be you declare what this environment should look like, versus imperative tells you all the steps that you have to do. But you want to have a system that converges to the declarative state. And that's really a benefit because what you declare is what the environment should look like, and you can actually compare those two. So let's take a look. So from an operator perspective, you want to source everything from a registry that has been approved. There's security pieces in place, and you don't just push into production. You try to do more of a pull approach. But then there's this notion of a control loop. And control loop is an interesting pattern where you look at the declarative state, and the control loop really tries to converge to this state, constantly adjusting to get to this piece. But what's important with the control loop is that it has a notion of an admission controller, where you only admit things that, based on a set of policies, you actually put into the environment. So to get to those end state, you have to have a declarative state defined. So this is where practices like GitOps really comes in, where the declarative states is actually done in a Git repository, either a set of YAML files or whatever descriptive way you want to apply this. The point is that you declare what the environment should look like. And again, the control loop really tries to converge to that particular state. And so from a configuration perspective, you can always look back at the declarative state as what it looks like. But now the control loop, from an admission perspective, needs to look at the metadata store and its policies to define, like, what should I allow in the infrastructure? For example, based on a risk scoring profile, or if certain attestations have been done, or if certain vulnerabilities are not there. And then based on that, it actually will start building out what the infrastructure and environment looks like. And that's what gets pushed in as well. And again, the environment tries to converge to this control loop. So you also want to make sure that when things are actually get deployed, you have that fed back into your metadata store. So the metadata store has a representation of what I declared versus what's actually in the environment. And I can then do some drift analysis when it occurs. And this becomes a lot easier to identify vulnerabilities in the system of things are running that not supposed to be running. I declared state A, but state B is in place. So now I can have a more targeted and quicker analysis of what is in the environment and remediate that as well. And this is where things like observability become key as well as a feedback loop in the operator side, but also from a developer aspect of it. And again, you can then perform the risk analysis, what I indicated, on the metadata store. So to sum this up, I think there's a couple of key elements that need to happen. Number one, bill of materials need to be generated so you can actually rationalize over the components that exist. Two, leverage the trusted repositories that have already done vulnerability scanning and artifacts are signed. So for example, leveraging concepts like Harbor and Notary for signing those images. Three, use attestations and identities to help support your compliance department. So every step along the way is attested to. Four, have environments that are declarative and sourced out of Git. This helps you to know when there's drift. Five, immutable infrastructure and continuously repaving. Repave your infrastructure continuously. And continuously build when upstream dependencies change. This removes a massive amount of toil on the developers, and you always have a consistent packages in place. Doesn't mean you have to release, but it's always releasable. And seven, provide dependency management, looking at your complete infrastructure and what's out in your supply chain, and have a metadata store that allows you to rationalize over. So with that, thank you for your attention, and look forward to the next couple of sessions in the summit.
Hi, everybody. This is Henri. Hopefully you enjoyed the session, and I'll hang around for any questions and I can answer. Thanks, Robert. Thanks for By the way, I created a poll as well. I'd love to kind of get everybody's feedback as well and get some quantifiable data based on what you're seeing in your industry. Great question from James. How does DevSecOps differ from GitOps? Yeah, so I think actually GitOps is actually specifically target on the operator side of the house, so the infrastructure aspect of it, versus DevOps initially is the whole flow of addressing the concerns of the operator about stability and the developer side of the house. And now with the introduction of the security concerns with DevSecOps, it covers a larger breadth of end-to-end capabilities, versus GitOps is very specific on one aspect of it. But great question. I think GitOps is one of the key practices in the operations side of the house to really get to declarative states and immutable infrastructure. Hope that answers your question, James. Thanks for the feedback, Nico. A question from Naveen is, what is the role regulations should play? Yeah, that's always an interesting question of how much regulation should be in place. I think regulations has a good place to help shape the narrative of what are critical things that across the vendor space and the industry aspect should be there. So I tend to believe that the open source community can help drive a lot of these things because a lot of people are coming. So think about, as an open source community, being able to help drive this. But institutions like NIST and ITA have kind of been driving some of these things without the regulations. However, in the energy space, there's regulation that's coming out in the United States, at least, around bill of materials. So that's actually a good thing. It's actually forcing things in the industry. So I think it's a combination of regulations and the open source community really coming together. Yeah, absolutely, Nico. Having a good supply chain in place for the open source is very critical, because you're, at 90% of open source being used in packages. It's critical that you are actually taking some responsibility of securing that supply chain and using the practices that are already there, like attestations, bill of materials, scanning for vulnerabilities. This is some basic pieces that are there. Great question. And again, more and more open source tooling is in place as well to kind of simplify these things. Like from attestation perspective, things like Intodo, open source project that is out there, KPAC for help building things more in an automated way. So I think there's a lot of good open source projects as well to simplify the supply chain aspect. question: who audits the auditors? Part of that is a little bit of a trust aspect of it, but I think by automating the attestation capabilities, you're actually opening that up a little more, that you're actually proving things out. But then again, it's a good question. I'm not familiar with the auditor side. I think it's still a good question of like, how do you establish trust amongst auditors? I think first things first is getting attestations and cryptographically providing those, so it's open and transparent to everybody what has happened by who, when, and where. Great, thanks, Naveen. Well, I think we're top of the hour. So thank you for attending the session. Enjoy the rest of your day.